All right, we're back for round two. I just want to go over one thing before we start with the next problems. If you look at the answers that I just redid here and put, these are the correct ways to write the answers. All right, obviously, I had x equals 0 there and x equals plus or minus I here. But we're going to end up combining those together with the squiggly parentheses, x equals plus or minus I, comma, 0. And for the next one, x equals squiggly parentheses 0, comma, 5 over 2, close with the other squiggly parentheses. Just do your best with those. All right, as we continue here, again, making sure that we have each side equal to 0. All right, so here we got a difference squares. All right, difference of squares. So again, at this point, you should be pretty good with difference of squares, difference of cubes, sum of cubes. So I'm going to go right into it. X to the fourth is a perfect square, and 64 is a perfect square. So we have a difference of squares here. So when we take the square root of x to the fourth, we get x squared plus square root of 64 is 8, and x squared minus 8. All right, before we do anything, we got to make sure that this is all done as far as being factored. All right, there's no such thing as a sum of squares, so that can't be done. And the other one is x squared minus 8. X squared is a perfect square. 8 is not a perfect square. It is a perfect cube, but that won't work here. So we are all done with factoring. So I'm going to split these up like so. So we get x squared plus 8 equals 0. All right, and we're going to get back into our square roots here from last unit, so be ready for that. We need to subtract 8 from both sides. And we get x squared equals negative 8. All right, I'm going to pause that for just a second and go over to the next one. I'll be right back to that one. X squared here minus 8 equals 0. All right, so we need to add 8 to both sides, so very similar, plus 8. All right, so we end up getting x squared equals positive 8. So I want to finish this one before we go over to the other one. The other one has an imaginary number, as you can see. We'll get to that in just a moment. So take the square root of both sides to get x by itself. We end up with x equals, okay, so we can't do the square root of 8, all right? So we need to think of factors of 8 that have a perfect square in them. So our factors of 8, 1 times 8. We also have 2 times 4, all right? When I say 4, you should think, it's a perfect square. What's the square root of 4? Square root of 4 is 2, so we're going to take that to the outside. It's going to be plus or minus 2 on the outside, square root of 2. All right, so that is our first answer there. All right, again, the factors of 8 are 4 and 2. 4 is a perfect square, so we take the square root of 4. That is 2. Put that on the outside. What's left inside is 2. If you have your notes from square roots, go back and look at those. Work on some of those problems. That way you are fluent with this, and we can just go right into it without having to go through another lesson of something we've done previously here. Okay. All right. So plus or minus 2 square root of 2. So let's look at what happens here when we have a negative number. Okay, because it's going to be a little bit different. So we're going to take the square root of both sides here. Now we have a negative. Negative. Remember, you can't take a square root of a negative. So, as I said previously, first thing that we need to do is take an I out, right? Take an I outside. All right, so this is going to be x equals plus or minus I. Now, what does that do? That gets rid of our negative sign, right? So that I is on the outside. Now what we have is the square root of 8. We just simplified that already on the right side of this problem. So when we do that, we end up getting x equals plus or minus 2i, because we multiply that to the I, it's just 2i, square root of 2 on the inside. And you can see how similar these are here, right? This one is x equals plus or minus 2 square root of 2. We don't have any I there because 8 was a positive number. On the left side, you see that we have a negative sign inside of the square root. Can't have that, so that's where this I comes from right here, right, and that gets rid of our negative. So whenever, again, you have a negative inside of a square root. Now, it's different with a cube root. You can have a negative cube root. You cannot have a negative square root without taking out an I. All right, so again, we'll continue to see this over and over again. All right, hopefully you can kind of adjust this and see the patterns that we're creating. All right. Let's do the, and by the way, our answer here, if we're going to write this the best way possible, x equals plus or minus 2 square root of 2. It doesn't matter the order here. Comma, plus or minus 2i square root of 2 inside of the squigglies. All right, that's our answer there. All right, let's go to the next one. All right, do we have a GCF? Yes, we do. So GCF is going to be 5x GCF. 5x, we're going to put that outside of parentheses. All right, so 5x outside of parentheses. Inside of the parentheses, we have x to the fourth minus 16 equals 0. Again, we didn't have to move anything to the left side. We had our original problem was already equal to 0. All right, so that saves us a step. All right, are we done with this? It's a question you always have to ask yourself. No, we are not. In fact, we're not going to be done with this for quite a while. All right, so pay attention here. All right, right here we have a difference of squares. Okay, so again, the square root of x to the fourth is x squared. All right, square root of 16 is 4. All right, so what we end up with is 5x on the outside, x squared plus 4, just doing our difference of squares, and x squared minus 4. All right, all equal to 0. Are we done? No, we're not. This is another difference of square. All right, so again, just always have to be cognizant of this and keeping an eye after each time we factor to make sure that we are, in fact, done. We're not yet. All right, so again, the square root of x squared is x. Square root of 4 is 2. All right, so we end up with 5x times x squared plus 4. And then x plus 2, x minus 2 for our new difference of squares that we had to take care of. All right, and there we go. Now, if you notice this, we have let me use a different color here. 1, 2, 3, 4 different factors that we need to set equal to 0 and solve for them, okay? Kind of running out of space here. I'll do my best. So first one is 5x equals 0. All right, I'll use a different color to make this less confusing. 5x equals 0. We divide 5 to both sides. We end up getting x equals 0 for the first one. All right, next one is x squared plus 4 equals 0. Subtract 4 from both sides, minus 4. All right, we end up getting x squared equals negative 4. All right, now here we go. Taking the square root of x squared to get x by itself. Square root of negative 4, again, used to be illegal, now is not. We have a negative sign, so immediately that tells you that I is going to be coming out of the square root. All right, and what is the square root of 4? Square root of 4 is 2, so this is plus or minus 2i. Okay, so x equals plus or minus 2i. All right, x plus 2 equals 0. Subtract 2 to both sides, and we get x equals negative 2. And then finally, x minus 2 equals 0. Add 2 to both sides. X equals 2. So the big concepts here, right, and again, kind of running out of space here, but I could write this answer out as x equals 0, comma, plus or minus 2i, comma, since we have a positive 2 and a negative 2, we could also do, comma, plus or minus 2, right, because we have one positive 2 and one negative 2. But again, the big concepts here are, can you factor this out completely? All right. set all of those equal to 0. And then last but not least is, can we simplify our square roots? And again, we can't have any undefined answers here. We need to make sure that we are taking out the I whenever we see a negative. Right? So if you see a negative square root, the first thing you should do is take the I out, make it plus or minus, and then go ahead and simplify the positive number inside of the square root. All right. All right. Let's see here. I'm going to, for the rest of these, I'm kind of going to bounce around here. All right. During class, I would have you guys do some of these on your own. I will post the rest of the answers to the notes, but I will just go over the evens with you guys so that we can get this finished up. If you want to do the odds to make sure that you know what you're doing, that's fine. Again, I'll be posting a homework assignment for you as well. But I will post the rest of the answer key to the notes. And if you guys have any specific questions about that, if you're confused on anything, please just let me know. All right. So for number 6 here, all right, the first issue that we have is we need to get 4x squared to the other side, and there is a like term over there. So when we subtract 4x squared, again, I can't zoom in, makes it a little bit tough. 4x squared minus 4x squared. Find the like terms, minus 4x squared. We're left with, this side's going to be 0 over here. All right, this side will be 0. All right, so we're left with 8x to the 5th plus 5x minus 5x squared minus 4x squared plus just x squared, 1x squared, and that will equal 0. All right, great. Do we have a GCF? We do. All right, the GCF is x squared. So we're going to take the x squared, put that on the outside, divide. All right, so we end up with 8x to the 3rd plus 1. And that's equal to 0. Now, are we done here? No, we are not. All right. What we should see here is that we end up having a sum of cubes. All right, a sum of cubes. So right here is our sum of cubes. All right. Now things start to get a little bit tricky here. All right, we are going to end up having to do quadratic formula, which I will do. And this is part of the reason why I'm not doing the odds. I want to make sure we have space on the left side to do the quadratic formula, which is something that we're going to need to do here. Yeah, the quadratic formula is back. All right, so we have a sum of cubes. Okay, so remember what our sum of cubes is. All right, a plus b, parentheses, a squared minus ab plus b squared, close parentheses. All right, so we need to find a squared. A squared is going to be, or excuse me, we need to find a. All right, the cube root of 8 is 2. The cube root of x squared is just x. All right, so that's going to be a. And b is going to be, the cube root of 1 is 1. All right, so rewriting this out, we have x squared. Now I'm plugging these back up into this, okay? So 2x plus 1, parentheses, a squared is 4x squared. Minus 2x plus 1. Right. So can we simplify anything else from here? No, we cannot. All right, so now we have our 3 factors, 1, 2, and 3. You can see them. All right, so we're going to divide those up with my lines as we've been doing. We get x squared equals 0, which means when we take the square root of both sides, we should be getting used to this. It's just x equals 0. 2x plus 1 equals 0. Subtract 1 from both sides. We get 2x equals negative 1. Divide 2 to both sides. We get x equals negative 1 over 2. All right, that's our next answer. And then finally, for this one here, we have a trinomial. All right, so we need to do quadratic formula here. Yep. Yeah, I don't think that was going to go away. All right, we got to do quadratic formula in order to solve for our answers for x. All right, this is exactly what we did in the past. It's just now we're really applying it instead of just going right into it. All right, so again, if you have a trinomial that cannot be factored in the ways that we've used in the past, okay, whether that be the special factoring of trinomials, garbage method, all right, any of that. In this case, you could use garbage method, but again, we're going to end up with an imaginary number. So stick with quadratic formula when you're given a trinomial that you cannot factor in just the normal simple ways that we factored in the past, okay? So quadratic formula, I'm going to do that over here on the left side, all right? So we end up getting 4x. I'm just basically writing that column out. 4x squared minus 2x plus 1 equals 0. Our quadratic formula. When we plug it in, we end up getting x equals 2 plus or minus the square root of negative 2 squared minus 4 times 4 times 1. And that's all going to be over 2 times 4. All right. So when we go ahead and do this, all right, we're going to simplify it. When we simplify the inside, negative 2 squared, we end up getting 4. 4 minus 16, all right, it's going to give us a negative 12. So again, simplify it, rewrite it out, all right, and 2 times 4 on the bottom is 8. So x equals 2. I'll do this in a different color. That way we can see the difference here. X equals 2 plus or minus, when we simplify the inside, we end up getting a negative 12 with an 8 on the denominator. All right, now we're almost done. All right, we're almost done. We cannot, normally we wouldn't be able to do the negative 12 on the inside, okay, but here now we can. All right, so again, we're looking for factors of 12, all right, that have perfect squares in them. All right, so we end up having negative 4, okay, negative 4 times 3. All right, so again, we have a negative, so the first thing we need to do is put an I on the outside. All right, so x equals 2 plus or minus, because 12 is negative, we need to put an I on the outside. What are the factors of 12 that have a perfect square in them? 4 and 3. 4 is the perfect square, so the square root of 4 is 2. I, that's where the negative is. We move the negative to the outside, make it an I, all right? And we're left with the square root of 3 on the inside, all over 8. And we are very close to being done with this, all right? But we can simplify it, as you can see here. 2, 2, and 8. All right, they all have a GCF of 2, so we can use division here to end up giving us our answer, which is x equals 1 plus or minus I square root of 3 all over 4. And you might be looking at this going, geez, it's just quadratic formula, and you guys have done this before, all right? And this wouldn't be any different. The only big difference here is this I that we have on the outside, and that's all because of the negative that we ended up having to take out, all right? The square root of 12, if we were to simplify that, it would be 2 square root of 3, which you guys have all done. We've done them in quizzes. We've had it in tests, all right? But if it's a negative, the big difference is we just put an I on the outside there. All right, so it is basically the same. Just again, if it's a negative, we have to make sure that we have an I on the outside as well. All right, let's do a couple more here, and we will call it a day. 16x to the third equals 54. First thing we have to do is make the right side equal to 0, so I'm going to subtract 54 to both sides, and I end up getting 16x cubed minus 54 equals 0. All right. Do we have a GCF? Yes, we do. The GCF is 2. Let me get rid of these dots here. All right, so 2 is going on the outside. We're left with 8x cubed minus 27 cool, and that's equal to 0. All right, we have a difference of cubes on the inside here. All right, difference of cubes. So, yeah, quadratic formula is coming again. So here we go. Excuse me. 2. All right, the square root of, the cube root. Basically taking the cube root of this and the cube root of this. All right, that will be a. So a equals 2x, and b equals the cube root of 27 is 3. All right, so we're plugging that into the difference of cubes formula. All right, so 2. We end up having 2x plus 1, a plus b, 2x I was looking at the wrong one. 2x minus 3. Parentheses, we have a squared, so 4x squared. Plus 6x, a times b. And then plus b squared, which is 9. Okay. Now we have our 3 factors. All right. So, boom, 1, 2, and 3. All right, so we need to set each of them equal to 0. 2 equals 0. Is that true? No, it is not. Okay, so that's not one of our solutions. All right, so we're just going to go ahead and put the line through that because 2 does not equal 0, so that is not a solution. Next one we have is 2x minus 3 equals 0. We subtract 3, add 3 to both sides, 2x equals 3. Divide 2 to both sides. We get x equals 3 over 2. All right, that is a solution. And then for this one, Mr. Ryan, how do I know whether or not I have to put it in the quadratic formula? If you see a trinomial, put it in the quadratic formula. Okay, put it in the quadratic formula. All right, so here we go. We're going to go ahead and plug it in. X equals -6. Oh, let's go ahead and write it like I did last time. Let's write it out. All right, we have 4x squared plus 6x plus 9 equals 0. All right. Now we're plugging in the quadratic formula. Notice I'm not giving you quadratic formula. You have this in your notes. All right. We worked with quadratic formula for many classes. We had it on our quizzes or tests. So again, go back in your notes. This is how you got to do these things. All right. Go back, find the quadratic formula. All right. Plug it in. Okay. So I'll plug this one in for you. All right. -6 plus or minus the square root of 6 squared. We can put that in parentheses if we want. It's not negative, so it's not essential. All right, 6 squared minus 4 times 9. Minus 4 times 4 times 9. I'm going to extend that over. It goes all the way over that. All over 2 times 4. Remember that this is A, this is 6 is B, and 9 is C. All right, that will help you plug it into the quadratic formula. All right, when we simplify the inside, all right, 6 squared is 36. All right, we have -4 times 9. When we combine everything together, we're going to have -108 inside of the square root, and then of course on the bottom 2 times 4 is 8. So let's rewrite this. X equals, take it one step at a time, -6 plus or minus the square root of -108. Oh boy, another negative inside of a square root, so we're going to have to deal with I again, right? And 8 at the bottom, at the denominator. Okay? So we're at the point where we need to simplify the square root. There's nothing else we can do here, right? Square root of 108, square root of -108, okay? So if we are trying to figure out the biggest perfect square that goes into 108, all right, that might take some time. Remember, divide it in half, right? And then start with that and go from there, okay? So when we do this, we're going to look at this and say that 36 times 3 would give us 108. Let's make that a -38. Excuse me, let me say it one more time. -36 times 3 gives us 108. 36 is a perfect square. If we take the square root of -36, right, the square root of regular 36 is just 6. Right? But since this is negative, it will be a 6i. And because 3 is not a perfect square, that will stay outside as square root of 3. So when we simplify this, we end up getting x equals -6 plus or minus 6 plus or minus 6i square root of 3. All right. All over 8. Are we done? I wish. We're not quite yet. All right. We have -6, 6, and 8 all, which have a GCF of 2. So at that point, we just need to simplify it. So we get x equals -3 plus or minus 3i square root of 3. We're just dividing by the GCF, which was 2. All right, so there's our answers here. All right, this guy right here is one of our solutions, and once we finish the quadratic formula, that is also one of our solutions. All right. Well, that's 27 minutes now in this video. Okay, I went through a bunch of these. I will post the rest of the answer key as far as for the notes. All right, and I will send out the homework assignment as well on which problems I want you to do. I'll probably only have you do a couple of quadratic formulas since we only were able to go through a couple in class. Do your best on those. Okay, seriously try to persevere through those as much as you can. We've done quadratic formula. All right, take risks and see what you can do. If you have any questions, send those questions to me, bryanarchbishopcurley@gmail.com. When you're submitting notes in the assignment, which for section 2 is due tomorrow, 3/18. All right, for the other sections, I will post the specifics as to when they are due based on when our class would meet. Again, those any homework assignments that you're posting to me should go directly to my school account, bryan@archbishopcurley.org. Okay. Awesome, guys. Keep up the good work. Appreciate you guys, focusing and following through with this, and just being flexible and dealing with the situation. So, kudos to you guys. Keep up the good work, and I will talk to you soon. See ya.